Okay, so today I'd like to explain the spider matrix problem in C++. Spider matrix problem is given m by n matrix and return one-dimensional array in spider order. What does that mean is if there's a two-dimensional matrix, we want to return all elements in spider order. So our result is going to be one-dimensional array 7, 8, 9, 8. Oops, it's going to be 9, 8, 7, 4, 5, right? So since it is a n by n matrix, it doesn't need to be square. So it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we're going to return this sequence. Then output is going to be 1, 2, 3, 4, 8, 12, 11, blah, blah, blah. Then how can we do this? What we can do is actually follow as this sequence. 1, 2, 3, and we're gonna create the result vector. We're gonna push first row 1, 2, 3, and erase it. Then we're gonna do counterclockwise rotation. And then we're gonna push first row and erase it. Counterclockwise rotations 7, 5, 4. Push, erase it. Counterclockwise rotations. Push 4 and erase it. Counterclockwise rotation is gonna be same, and then we're gonna push, erase it. Then once matrix is empty, then we're gonna stop. So given matrix, if the matrix is becoming empty, we wanna stop. Then we need to know like how to do counterclockwise rotation, right? What we can do is we can actually transpose the matrix first, and then we can flip by um, top to bottom, because if there is a 1, 2, 3, let's say 5, 6, 7, 8, 9, there is a 2 by 3 matrix. Oops. Then we want to create the 3 by 2 matrix to transpose matrix, and then this first row becoming the first column, this second row becoming the second column, right? This is the transpose, and then we're gonna flip we're gonna starting from this index first row, and we can set up the end index, and we're gonna use these 2 pointers. Then we're gonna swap it 6, 9, 5, 8, 4, 7. Then next iteration start is gonna be here, and it's also gonna be here. Okay. Then we're gonna stop iteration because actually our condition would be flipping by top to bottom. So if start / end, then we're gonna keep doing. Otherwise we're gonna stop. So once start index and end index becoming same, or starting index is greater than end, then we want to stop. Okay. And it is optional. We can also do clockwise rotation. There are 2 ways. We can change the sequence, flip by top to bottom and transpose. This is the first method. Second method is we can do transpose first and then flip by left to right. What does that mean? It means let's say we wanna do clockwise rotation here. Then our result is gonna be 7, 4, 1, 8, 5, 2, 9, 6, 3, right? To do that, we can transpose 1, 5, 9. It's gonna be change it. It's gonna be 3, 7, 8, 6. Then we are gonna do flip by left to right, and then our index starting from here and end index starting from here. Okay, and then we are gonna swap it. Let's write it here. Swap it, and then this index is gonna go to here and here, and end index is gonna be decremented. Start index is gonna be incremented. Then once start index and end index becoming same, or start index is greater than end, then we're gonna stop. Then we're gonna actually pointing out the next row and next row of the endpoint. Then we're gonna swap it, which is gonna be 8 to 5. Then it's gonna go this way again, and we're gonna stop. Same goes for here. We're gonna swap it and like this, which is the same as like clockwise rotation. Alright, so then next we are gonna jump into the code. Now we are here. This is the spiral matrix problem as I described in the LeetCode. And we're gonna solve using C++. First, I wanna do is like I wanna use the abbreviations matrix as a vector int, because like it will take a lot of time to write everything like this. Also, it is more intuitively better to understand. Then we're gonna loop through, and if matrix is empty, if it is not empty, we are going to iterate it. Otherwise, we are going to stop it. And we are going to make the result vector, which is the array, dynamic array. And then we're going to push. We're going to iterate through, and we're going to push back. And we're going to iterate through for the column, because as I told you, we're going to fix the first row to push like this, and then we're going to iterate through column 1, 2, 3, and then we're going to push back. Okay, next thing we need to do is we're going to erase the matrix, first row matrix, then we can erase it using the iterator. Then we're going to erase it. Next, we're going to do counterclockwise rotation, which is going to return the matrix. Let's do this. Of course, we're going to return a result vector, but before that, we need to make the clockwise rotation function. Return matrix. Oops. Then we're going to make the temporary variable. And also, since we are not going to do in-place operation, in-place matrix operation, we can actually use it constant. Okay. And then temporary matrix is going to be if the matrix size is 3 by 2, for example, our temporary matrix is gonna be 2 by 3. So it's gonna be the opposite size. We're gonna take the column size as a row, and then matrix dot size row as a column. Okay, and we're gonna transpose. Say element is gonna be temporary column comma r element. Okay, after transpose, we're gonna create the start index and the index as a temporary size of the temporary size -1. And we're gonna iterate through. If start is less than end, we're gonna keep iterating through. During iterations, we're gonna swap temporary start, temporary end, right? And then we're gonna start plus plus and the minus. I think that's it. Looks good to me. And if you run the program, let's see if there is error. They're complaining about we didn't return a matrix. Okay. All right. It looks the test, we can pass the test, but let's make sure if it is actually working well. We're gonna print matrix and we're gonna pass the matrix. We're gonna print matrix, and we're gonna iterate through, see out. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we're gonna erase. We're gonna push to the results vector and then erase it. And counterclockwise rotation 6, 9, 5, 8, 4, 7. Then we're gonna push 6, 9, and then we're gonna erase it. Then counterclockwise rotation, push back, and erase it. Counterclockwise rotation, yeah, that's what we expected. And just to make sure, like, what if we wanna starting from the 7? Like, what if our desired output is gonna be like 7, 4, 1, 2, 3, 6, 9, 8, 5, for example. Like, you know, starting from the 7, not the first row, 0, comma 0. Then actually we can rotate it by clockwise rotation. We can do clockwise rotation. Then we can do the same thing. And let's check this. And let's check we can make also clockwise rotation. Matrix. Matrix is gonna be like this. Clockwise rotations. Matrix. Matrix. And it's gonna be almost same as counterclockwise rotation. Let's copy. Let's copy this. We're gonna transpose first. Okay, so it should be okay. And this part, we're gonna change it. Now we're gonna loop through row, temp.size plus plus, and then start index always 0. Temporary, the end index is gonna be the last column of the temporary. So first it's gonna be 2 in this case, like 0, 0, 1, 2, the second index. And then we're gonna swap it. Since we get some row value, we're gonna put the row value here. I think that's all. Let's see if it is, if the output is okay. As we expected, we're not gonna pass the test, just to check if the 741 852 963. Yeah, it was rotated by clockwise rotation. And then if you just comment it out, oops, as expected, we can just pass. Yeah, that's the whole idea.